In this video, I'll demonstrate how to perform fluorescence measurements using Ocean Optics equipment and software. We will talk about the required equipment and setup and how to optimize your measurements for best results. In this video, we will use fluorescein as our fluorescent sample. The equipment used in this setup is as follows. The flame spectrometer configured for UV vis, two 600 micron UV vis patch cords with SMA connectors, a CUV cuvette sample holder with two 74 UV collimating lenses positioned at 90 degrees to each other, two mirrored screw plugs positioned opposite to these lenses. This helps to maximize the fluorescent signal, and an Ocean Optics LLS light source containing an LED which gives out light at 470 nanometers. This particular LED was chosen because the peak excitation wavelength of fluorescein is close to this value at 490 nanometers. This will vary depending on your fluorescent sample, so make sure to look into which light source will be most useful for your application. Other considerations include keeping the wavelength of your light source distant enough from the peak emission wavelength where you're expecting to see the most fluorescence from your sample. You don't want the two wavelengths to overlap too closely, as it can make it difficult to see your fluorescent signal. To set up the instrumentation for fluorescence measurements, we simply connect one end of a patch cord to our light source and the other end to the sample holder. We then attach the other patch cord at 90 degrees to the last, and the other end of that to the spectrometer. To ensure no scattered excitation light is being measured as fluorescent, a narrow bandpass filter can be used to attenuate any extra light other than the fluorescent wavelength. The CUV cuvette holder also comes with a cuvette cover that can be placed over the sample like so, to prevent any external light getting into the system. Finally, make sure your spectrometer is plugged into your computer with the micro USB cable and switch on your light source. Now you have set up your experiment, open up the OceanView software. You will see the raw spectrum of light being received by your spectrometer. Select the Spectroscopy Application Wizard from the pop-up window or Create New Spectroscopy Application, which can be found in the top left corner. Then choose Fluorescence from the menu. You will be presented with a screen to choose various parameters. To choose a suitable integration time, insert your sample into the cuvette holder. You will want the highest point on the spectrum to reach up to about 85% of the maximum signal that your spectrometer can receive before it saturates. This is indicated by the blue line shown here. However, fluorescence often gives low signal spectra, and for the purposes of this, a lower signal which still has a clear peak is suitable. You can also choose the number of scans to average for each acquisition, and the boxcar average is applied. Both of these parameters adjust the smoothness of your spectrum. Choose whether to select electric dark and nonlinearity correction, both of which we recommend to select. Next, you will be asked to take a dark. Do this by closing the shutter or turning off your light source. Click the grey light bulb and then finish. Switching your light source back on, your fluorescence measurement can now be seen in the View minus Background tab. You can capture the current spectrum using the camera icon at the top of the screen. You can also look at the schematic window to see the functions that are being performed for your fluorescence measurement. If you want to change the acquisition parameters, make sure you take a new dark using the bulb icon at the top of the screen. So that's it! Fluorescence is simple once you know all the details to watch out for, and Ocean Optics spectrometers, light sources and accessories provide a versatile platform to do it with. The expertise of our technical team is available to help if you're unsure which light source or setup would be best for you.